Welcome to the session on revolutionizing developer experience with automated platform engineering and DevOps. So today in this session, we are going to discuss about various topics related to automated platform engineering and DevOps, like what is the challenge, what is the solution, what is the platform engineering, internal developer portals and DevOps, and internal developer portal benefits, platform engineering in coordination with internal developer portals, sample IDP tools, metrics, and continuous improvement strategies, and conclusion. So here we're going to discuss about like how platform engineering, DevOps in coordination with internal developer portals can enhance developer experience in any given project. So let's talk about the challenge. Today, the software development landscape is rapidly evolving, putting immense pressure on development teams to deliver high quality applications at an unprecedented pace. Yes, we all know that today the competition is very high and companies has to compete to deliver high quality products in a good time to market, along with competing with the competitors. And we all know that there are different teams while developing a software product. So we have dev teams, development teams, and rest of the teams. And development teams are development teams the success of the product totally depends on how good the development team focus and innovate the product and deliver it successfully. So the important aspect is that companies has to invest on enhancing developer experience and like how quickly developers can onboard themselves and work on any given projects and focus on innovation. So the second point talks about the developers often spend unreasonable time doing undifferentiated heavy lifting rather than focusing on application code. So let's take an example. Suppose we are like a developer picks a microservice, Java microservice running on cloud Kubernetes cluster in a given company. Generally, when they want to start working on a microservice, so they need to do a couple of things, prerequisites for the projects, like create GitHub repositories, and they need to write build scripts, and then they need to run CI/CD pipelines, and run Terraform scripts to provision infrastructure, create Docker files, and Kubernetes deployment manifests. Like in today's world, even though the microservices are designed in such a way that all of these stay in the same project, they don't technically need to write them, but still they need to initially struggle to make it work, and then they can focus more on their application code. Yeah, I'm taking an example of, let's say, for example, there is a new developer who joined the company. So they are not aware of the tech stack. They have no clue how things work in the company. And then they're given a task like, hey, can you start working on a microservice? What the general developer trend is, okay, they go to any existing repository, like maybe pick somebody else's repository, they probably clone it and then, start tweaking it to make it work, to make it work. And then that may take at least a day or day and a half to make it work. And if it is a new developer, it takes a lot of time for them to connect the dots and to understand what exactly is happening. So yeah, these are the general, yes, that's what I was mentioning in the other point, that general developer tend clones other repositories and tweak names code, more error prone, repeated iterations, and frustration. So yeah, it takes a lot of time for them to get to a working state of the repository to even start writing their microservice code. So all these activities hinder developer productivity, taking away their focus away from core app development, and especially can be more challenging for new developers who joined recently searching for information. So as I told, if there's a new developer, they have no clue, they just take some other microservice repository and start working on it. There's a lot of struggle. It takes time. And then obviously not every developer really knows all this. Maybe some of the developers may not have their knowledge stepped into this Kubernetes, Terraform, or CI/CD, and build scripting, etc. Yeah, and then they have to take time to tweak an existing code. Yeah. There is always some pressure point there. Yeah. Now, Again, so it all comes to the solution. Hey, how soon can I get a quick environment to develop, deploy, and test code right away? So I don't want to spend a lot of time, and I want things have to happen a magical way of doing things. So in that aspect, so we have, that's where the platform engineering facilitated by internal developer portals presents a strategic approach to eliminating these challenges. Yeah, again, platform engineering in some of the companies, like platform engineering constitutes most of the time. The DevOps team is part of platform engineering. Then you have depends on the company. You can have it's a platform as a service, like where you have DevOps teams, infrastructure teams, and there are development teams. So it is like a platform. And then and DevOps team is part of the platform engineering. And then now IDPs. So now coming to the internal developer portals, IDPs provide pre-opinionated and pre-configured tools and environments, freeing developers to concentrate on their core responsibilities. So again, these internal developer portals can be maintained by DevOps team. And then also, as in the previous slide, I was talking about the CI/CD pipelines, or the Kubernetes infrastructure, or the Terraform manifest, CI/CD pipelines. All those can be managed by DevOps team in the backend, and internal developer portals. And then internal developer portals can be used by developers to quickly provision repositories. Let's talk about it in the next slide. Yeah. Now, what is platform engineering? Primary goal of a platform engineering to lessen the cognitive burden on developers by offering automated process and reliable tools, design, development, and management of a combination of software and hardware frameworks that provide foundation for developing, running, and managing applications across the organization. Yeah. And obviously the key aspects of platform engineering is development platforms. So again, it's auto provisioning of development environments such as code repositories, build scripts, tests, skeleton codes. If I'm using a platform, if I have a platform and I use the platform, how soon can I get a development platform? So I can quickly do things and start my coding right away. And then the deployment pipelines. So the platform should give me the deployment pipelines. For example, automated CI/CD pipelines to release software at any time. For example, GitHub. For example, if I'm using if I'm using GitHub as a CI/CD, then I need GitHub workflows. And if I'm using Jenkins, I need Jenkins pipeline scripts, etc. And then I need an infrastructure to be provisioned automatically. So I need some automated scripts to run in the backend to provision infrastructure, like a Terraform, a CloudFormation, whatever I use. If I'm Terraform, I can use CloudFormation, etc. And then interoperability and integration. So makes it easy for new technology integrations and rollout. So again, platform engineering provides you both software and hardware. So any new things that you want to roll out across the enterprise, or you can all integrate them into the platform, and all the rest of the teams gets benefit from the platform. Yeah, that's the idea. Now, internal developer portals and DevOps. Interface between developer and let's talk in this slide about what are internal developer portals and how DevOps team contribute to it, or how they are involved in this internal developer portals. Because end of the day, the topic that we are talking is, as we go on, the main important point is like the developer experience. Like the platform, through the platform engineering and IDPs, DevOps teams give a better development experience to the development teams, so they can quickly start coding and start innovating. Yeah. So internal developer portals are interface between developer and platform. Self-serve centralized hub for organization software development activities through an intuitive web portal. So you'll have a web portal where, let's go to we will see an example. Developers can provision fully configured environments for new projects by using ready-made templates. So you can have in internal developer portals, you can maintain templates where developers can go and quickly choose any template of their choice and then start coding right away. Let's look at, as we go on in the next slides, we'll see that. So log into Internet Developer Portal, choose template of your choice. So you can maintain Java, Node.js, Python, and provide inputs. So you can get your project name, project team, project email, etc. And then get all necessary setups within minutes to start coding right away. So let's say an example. So a GitHub repository. So for example, let's say the developer logged into IDP and then has done this, has given these inputs. What happens? So he or she will get a GitHub repository created for a Java microservice with a working hello world skeleton Java code and tests, a GitHub action workflow file for CI/CD, a Docker file, a Terraform file executed on a repository creation, that provisioned a dev test prod Kubernetes namespaces and an artifact repository to store artifacts. So here is an example. So let's say you designed your internal developer in such a way that like you just go and choose any template of your choice. For example, I want to choose a Java template. So I chose there, I just fill some inputs and then boom, like I in the backend, like now in the backend, this internal developer portal creates all the things for you. For example, it creates the GitHub repository, and with all this, what if it creates it gives you a Java code, a skeleton Java code, and then the CI/CD pipelines or like for example, it's a GitHub action workflow. So what if the CI/CD pipelines, as soon as a repository is created, then you have some conditions like to run certain things through the pipelines. They just like then these pipelines trigger the automated Terraform execution, and then the infrastructure gets created in dev, test, and prod. For example, you have a namespace created, and then you have your name. For example, you have your project name has a space in Artifactory. So the benefit is, as soon by the time this let's say this is executed in 3 minutes, and within 5 minutes you have a working environment, like you like your CI/CD pipeline ran in the backend, created the infrastructure, and then GitHub repository is created, and you just clone it and start working right away. And let's say what if like you have a Docker file, a template already there, and then you have a Kubernetes manifest already within the project. So then you just start like clone the repository and then start picking the Docker file. Yeah, and again, end of the day, it depends from organization to organization, but most of the time, all this like this management of all this together generally maintained by templates owned and maintained by DevOps. Infrastructure as code, CI/CD, Docker. So for example, we have multiple templates in your, I have a Java template, I have a Python template, or I have a Node.js template. And then maybe my requirement is different from a Java. For Java projects, my requirement is different. For Python projects, my requirement is different. So DevOps teams manage these templates. So for example, maybe they just want a different infrastructure for Java templates. So they go and in the backend, they maintain these templates. They check in that skeleton code of infrastructure required for Java projects. Or for Python projects, they can maintain the skeleton code of infrastructure for Python projects. Or they want CI/CD pipelines may be different. Maybe Java projects are hitting a particular CI/CD tool. Python projects are hitting a particular CI/CD tool. So all this can be maintained by a DevOps team. So yeah, it's interchangeable. In some companies you call it infrastructure team. In some companies you call it a DevOps team. In some companies you call it as a platform team. And within the platform team, maybe DevOps team is maybe a sub team of platform team. Yeah. Now, here is, as I explained in the previous example, after the developer has created this repo, here is a sample repository through IDP. So we can say, suppose my name of my microservice is my microservice A, and you can clearly see that I got a GitHub repository created with a CI/CD YAML, and I got a Docker file, and I got a Kubernetes folder with the underlying Kubernetes manifest files. And then I have a source main Java and source test Java files and Terraform file, and I have a build.gradle. So all these are coming through the template. As I told, like you have a base template from which this is a fresh repo created from the template. So now from here, the developer can start owning the repo and then tweak it as they like. The base. So the good thing of this is all the projects has a uniform structure. All the Java projects are on a structure. All Python projects can be in a structure. Yeah, let's look in next slide. What are the benefits that we draw out of this whole idea? Yeah, IDP benefits. Standardization and best practices. So ensures all teams follow the same best practices. More consistent and maintainable high quality code. Yes, that's you can have a standardization and the best practices, like whatever. Let's say the DevOps team they want a certain project in a certain format. So you're indirectly enforcing these best practices without causing pressure to development teams, and no pressure to the DevOps team itself. Everything is managed through the platform, through internal developer portals. For example, let's say, hey, I want to integrate a security. There is a security scanning tool. So you can just put it in the template, and put it in the CI/CD. So you're not even announcing, you don't need to go to each development team, hey, can you start putting these changes? Or you don't need to communicate manually. You just put it in your template and automatically all the consumers get it automatically. Yeah. Similarly, easy onboarding. So one-stop shop for all organization resources. New developers can quickly learn technology stack, and start contributing to projects right away. Yeah. In our internal developer portals, you can also maintain documentation templates where like developers can go and quickly see documentation on what's going on, what is the tech stack in your company. So you can have a team that is only specific for documentation. Maybe the document writers have their own repo and they can just maintain templates for it and then push it to the portal so that anybody can go and click and see what's happening and what is the tech stack in the company. And developer productivity boost. Centralized access to tools, documentation, API enable developers to focus more on coding and innovation and less of administrative tasks. As I told, see the difference before, it's a developer has to struggle to understand the underlying all the things. More than their job, they need to first make things work. And if it is a new developers, especially, it's going to be pretty big struggle. So you are boosting developer productivity. So they have a quick environment in minutes. So they can and they don't need to worry about what's going to happen in the backend, in the infrastructure. And obviously, if for any reason things fail, we always have a support. You always have a DevOps team with a support channel. You can have a Slack channel with DevOps support. They're always available anyway. Hey, I just created a report through IDP and hey, something failed. Can you check it? That way, it's like a feedback mechanism even for DevOps team, continuous feedback. Okay, if something failed, the particular DevOps team immediately fixes the team's issue, and then they also go and fix the template because they don't want to see the same issue for the next the team that clones a repository. So that's the beauty of managing internal developer portals. And the resource management, centralized monitoring and management of services and tools makes it easier for platform DevOps infrastructure teams to manage updates, monitor usage, optimize resources across organizations. So let's say some infrastructure is causing costs within the company, and then at some point DevOps team determine, okay, like maybe through some infrastructure resources being created through the pipeline is adding to the costs. Or like they want to increase them. For example, Java applications has grown bigger and they want to improve the memory limits. Or so they don't need to go and start like going to every developer and say, hey, start like, whenever you create a new project, start doing this. So they just go and update the template. Or sometimes they want to optimize certain things, or they want to improve infrastructure. So yeah, as I told, like everything is happening in the backend without knowledge of, no need to worry about communicating to the development teams. Yeah, and the cost management. So by improving developer efficiency, standardizing tools, and reducing administrative overhead, IDPs can lead to significant cost savings like infrastructure, software, return on investment, particularly for large organizations. Yeah, again, in developer experience and developer productivity is also a cost, because the more time they spend on non-innovation, they can get frustrated. Their happiness index can go down. But the moment they have a good process and tools around them, and they have all the support team around them, they'll be very happy. They will start focusing on innovation. They'll give the organization better products. So it's a return on investment. It's a cost. Obviously, it's every hour lost from the developer is a cost to the company. So it's a very good investment of actually thinking about developer productivity. Yes. Yeah. So platform engineering plus IDPs. So they go hand in hand, seamless integration of backend systems with front-end accessibility, and then obviously achieve more with less overhead across multiple disparate systems. As I told before, that your Java projects can have a completely different tool suite and infrastructure. Your Python projects can have a different tool suite and infrastructure. So you may have multiple, as I told, like there can be many things in your company. So you can streamline everything through platform engineering plus IDPs. Yeah, platform engineering creates the system and tools. IDPs make them accessible and user-friendly for developers. As I already told, it's user-friendly interface. So they just go and things happen magically. They don't need to worry about like the back-end platform, how things work. They don't need to worry about all this. Like they just get, hey, I went to the platform, I used IDP, I just filled inputs, I got my environment. Yeah, a dual approach for robust application and infrastructure across the organization. Yeah. And as organizations grow, platform can scale and evolve the infrastructure to meet increasing demands, and IDPs can be adopted to include new tools, resources, and support mechanisms. So, yeah, same thing what I was talking. The more the organization grows, the more complex systems come into picture. Platform engineering is very important. They can, as I told you, want to increase the infrastructure, you want to optimize resources. Everything can be done through platform. As I told again, the platform and the backend, as I told again, the platform is your backend CI/CD pipelines, or it can be like the infrastructure or the hardware and software. So you want to introduce a DevSecOps. That's what, for example, you want to introduce DevSecOps into your CI/CD pipelines. So you can do it on the platform, and then through the IDPs, developers go and clone the repo, and they get all this automatically through the platform. Yeah, automating routine tasks and streamlining process lead to quicker time to market and better quality products. Yeah, so the more automation you have, the more streamlined things are. You have a better time to market and better quality products. Yes. Yeah. And yeah, some of the famous IDP tools available in the market are Backstage, Conf42, APG API, Developer Portal, Swagger by SmartBear, Red Hat, Scale API Management, and README, Kong. Yeah, some of the IDP tools in the market that companies can quickly adopt. Yeah, here is an example of a sample IDP. Like when I took example of a Backstage. So this is how like your front-end portal looks like, my company catalog. So on the left side, you can see we have APIs, docs, explore, all these things. And on the right side, you can see all the available projects in your company. So who is the owner, what project is, who is the owner, what is the type, so description. So you can do, is there something called as, in Backstage, I'm talking about Backstage, there's something called as catalog info.yaml. So you can put in a repository, you can create a catalog info.yaml and fill in everything, and your IDP can, your Backstage can read that catalog info and start populating it on the front-end portal. Yeah. Yeah, so again, I was talking about creating a new component, sample templates. So here you can see like this particular project was like IDP was maintaining a documentation template and the Spring Boot service template and SSR template. Yeah. Yeah. So you can see that as I told, developer can quickly come and choose, and then choose this and start. You can see the description, create a new standalone documentation project, create a website powered by Next.js, or create a Sing microservice using gRPC and Spring Boot Java. So beautiful. You can quickly come to the portal, see all the templates. On the left hand side, you have all the filters, and I'll choose it and I will start creating my repo. Yeah, my project. Yeah. And here are some of the, yes. Yeah, here are some of the metrics that we gathered based on before project type, web app development, mobile dev, API services, or data pipelines and security tools. So now this is like a kind of a number of man hours spent before like having an IDP versus man hours spent after having an IDP. So you can clearly see that productivity has increased by a significant % on the projects. As I told, quickly developers get an environment and quickly the productivity is boost. So like a productivity is all about obviously how much time have you spent on innovation before. Like example, okay, you took a new project, how much time you got your environment, and what was the time you spent on other things other than coding versus before and then after is what the metrics is all about, and then we have a productivity boost. And then yeah, so metrics continued. So here we have some of the dev satisfaction before, dev satisfaction after. Again, the web apps, mobile apps, and APIs, number of developers. What was the satisfaction of the developers before the IDP and after the IDP? So improvement is 42. Number of developers who are satisfied with the available process versus after having IDPs. What are the number of developers who are satisfied with the process and tools around them? So that gives that improvement of the percentage. Again, it all comes to, this is a continuous, so in any company, this is a continuous process. So obviously there is no perfect platform or perfect software. So there's software needs to be stable all the time for sure. And then if there can be bugs for many reasons. So it's like a continuous improvement. So we need to always aim to continuously improve things. Now let's look at some of the aspects of how to continuously improve. Regular assessments. So assess platform infrastructure and applications for performance, cost, and scalability. So obviously you need to keep assessing your platform all the time to make sure that it's performing well, 24/7 availability, the performance is fast. You don't want to have developers feel frustrated about the platform or the platform you're providing. So it should always be perform the cost, and also you need to make sure that all the costs are under control, and scalability. So anytime you want to scale the platform, it should be quick. And automate more processes. tedious manual tasks should be automated as much as possible to free developer burden. DevOps team, wherever they see an opportunity. So wherever there is, let's say there is some place, I saw this. Oh, why is this not manual? I'm seeing in Java projects certain script or certain thing like that is manual. Oh, why is this manual? Why can't we just automate it quickly? There is a process that is manual, so you can write a quick script and to automate things and then put it into the template, and as soon as the CI/CD pipeline is created, that script runs in the backend, and by the time developer comes in, things are already in place, so that developers need not run it after getting the repository. Like again, I'm just giving an example. Maybe there is some manual process that you found. And feedback loops, regularly collecting and analyzing feedback from developers to identify pain points and areas for enhancements in the portal. That's what I said, like feedback loops. I gave an example before. Suppose there is a developer who went and used the portal and they saw an issue. They quickly inform the DevOps team, get the support. So the DevOps team quickly fixes it for them to unblock them, but at the same time go and start making changes to the template so that the further teams doesn't face the issue. It's like a feedback loops. And you can also maybe conduct some surveys every 3 months, quarterly, and then create a survey and ask like developers how they feel about the platform and the IDP, what changes they want to see. Yeah. And updating documentation, keeping the documentation up to date with the latest API changes, best practices and tutorials to ensure it remains relevant and useful. So yeah, documentation, sometimes like documentation is very important, because when new developers join the company, they need a tech stack. They want to get an overall picture of how things work in the company rather than sitting and connecting the dots. So maybe you can have a documentation per project. You can also induce this documentation within your microservice and then let it populate onto the IDP portal. So like people can quickly and say, okay, hey, what does this microservice does, like through catalog info.yaml I was saying. Or you can maintain documentation for the whole enterprise, like on the IDP portal. I go and check, okay, I can understand the tech stack quickly. Yeah. Tool integration. Continuously evaluating and integrating new tools that can enhance developer productivity and efficiency. So as I was telling before, suppose as I told, like you want to induce security into your CI/CD pipelines, you can quickly come and integrate a security tool within your CI/CD pipeline through templates. So, it's like a tool integration. So you are enhancing, again, it all comes to efficiency of the product you're inducing, so that when developers run their build or CI/CD pipelines, the security runs and then they get reports that you have vulnerabilities. For example, the security tool can find vulnerabilities in your project. So all these things can be integrated seamlessly through a platform engineering. And as I told, like platform engineering on the back end and IDPs in the front end, where developers can go and get the benefits. Performance monitoring, implementing and improving monitoring tools to ensure the portal remains fast and reliable. Obviously, you should have some tool monitoring and the portal itself to make sure that you don't want any downtime on the portal. Always high availability, so that, because that's the main portal where anybody in your company can go and take things and clone things and do a lot of things. So you always need to ensure that it's always up and running. You don't want, and then set up some alerting quickly if something is wrong. So you have an alerting mechanism set to quickly fix the portal and bring it back. Yeah, the conclusion part. So in the rapidly evolving software development landscape, platform engineering and internal developer portals have emerged as a game-changing solution to enhance developer experience and operational efficiency. By automating infrastructure management, providing pre-configured tools and environments, and streamlining process, developers are empowered to focus more on innovation. So that's what we were talking all this time. The whole purpose of the IDP's platform engineering is all about giving developers a good experience, improve their productivity so that they can deliver better products, and that benefits the enterprise and the company. Yeah. And thank you again for hearing this conversation, and I hope you were able to get some benefit from the conversation, and thank you very much again.